Let's begin with a question that sounds almost childish. Why can't anything go faster than light? Not how fast light is, not how close we can get, but why this speed of all speeds is the ultimate limit. At first, it feels like a technical problem. Maybe light is just really, really fast. Maybe we'll invent better engines. Maybe we just haven't tried hard enough. But the more you think about it, the more disturbing the question becomes. Because light speed doesn't behave like a speed limit on a road. It behaves like a structural rule of reality itself. And when Richard Feynman talked about this, he didn't pretend to fully understand it. He admitted something rare in science. We don't really know why nature works this way. That's what makes this story interesting. Let's begin with a question that sounds almost childish, almost too simple to deserve serious attention. Why can't anything go faster than light? Not how fast light is. We already know the number, about 300,000 kilometers per second. That's not the mystery. The mystery is why this number seems to be built into reality itself. Why is there a speed at all that the universe refuses to let us exceed? Why doesn't nature allow us to just keep adding speed the way we add layers to clothing on a cold day? At first glance, this feels like an engineering problem. Maybe we just haven't built a powerful enough engine yet. After all, history is full of limits that turned out not to be limits at all. People once thought sound was the fastest thing possible. Then light laughed at that idea. So it feels reasonable to ask maybe light speed is just another temporary ceiling. But the moment you look closely, the question stops behaving nicely. To understand why, we need to slow down and think about what we even mean by speed. Speed is distance divided by time. Simple enough. If I walk across a room, we can measure how far I went and how long it took. You and I will agree on the answer. But now imagine I'm on a smooth train moving steadily forward. Inside the train, I throw a ball straight ahead. To me, the ball moves at some speed relative to the train. To someone standing on the ground watching through the window, the ball is moving faster because it already has the train's speed plus the speed of the throw. Both descriptions are correct. No argument, no paradox. Speed depends on who is doing the measuring. This idea is so natural that we don't even think about it. Galileo understood this hundreds of years ago. Motion is relative. There is no absolute rest, no universal standard of stillness. So far, nothing strange. Now replace the ball with a beam of light. I'm still on the train. I turn on a flashlight and shine it forward. To me, the light moves away at a certain speed. To the person standing on the ground, common sense says the light should move faster because it's already riding on top of the train's motion. But when we actually perform the experiment, nature refuses to cooperate with common sense. The person on the ground measures the speed of the light and gets exactly the same value I do. Not approximately, exactly. No matter how fast the train is moving. No matter how fast the observer is moving. Everyone measures the same speed for light. This is not a trick. This is not a mathematical convenience. This is not a philosophical preference. This is what experiments say again and again with increasing precision. At this point, something has to give, because we cannot keep all of our comfortable assumptions at once. If speed depends on the observer, and light speed does not depend on the observer, then the things we were dividing by to get speed in the first place must be in trouble. Distance and time can no longer be universal. They cannot mean the same thing for everyone. This is where the universe quietly pulls the rug out from under us. Time, it turns out, is not absolute. Two people moving relative to each other do not agree on how much time has passed. Space is not absolute either. Lengths shrink depending on motion. Even the idea of two events happening at the same time depends on who is watching. These are not illusions. They are not measurement errors. They are the price reality demands in order to keep the speed of light the same for everyone. And here's the key point that often gets lost. Light speed is not special because light is special. Light is special because light reveals something deeper, about the structure of space and time. The universe seems to be built around a single conversion factor that ties space and time together, and that factor shows up as the speed of light. Once you accept that, the original question changes. It's no longer, why can't we go faster than light? It becomes, what would it even mean to go faster than the thing that defines how space and time fit together? This is why the problem refuses to behave like ordinary limits. You can exceed the speed of a horse by building a car. You can exceed the speed of sound by building a jet. But trying to exceed the speed of light is not like building a faster engine. It's like trying to build a triangle with 4 sides. You're not running into a technical difficulty. You're running into the way the universe is put together. And already, just at the beginning, we're forced to admit something uncomfortable. The universe is under no obligation to match our intuition. The rules that feel obvious to us are not the rules reality follows. And the speed of light is the first clear sign that the world is deeper, stranger, and far more subtle than our everyday experience suggests. Once you accept that everyone measures the same speed for light, you are forced into a corner. There is no clever escape. You can't fix it by blaming bad instruments or experimental error. You can't rescue common sense with a footnote. Something deep has to change. Imagine 2 people moving past each other. Each carries a clock and a ruler. In everyday life, we assume those clocks tick the same way and those rulers have the same length. We never question it. Time feels universal. Space feels solid. But if both people measure light and get the same speed, then they're measurements of distance, and time cannot agree anymore. There is simply no other way to make the math work. This is where Einstein made his move. Not a flashy move. Not a dramatic one. A brutally honest one. He said, if the universe insists that light's speed is the same for everyone, then we must give up the idea that time and space are absolute. They must bend to preserve that rule, and bend they do. Consider a clock that works by bouncing a pulse of light between 2 mirrors. Each bounce is a tick. Now imagine that clock moving past you. From your point of view, the light inside that clock travels a longer zigzag path than it does for the person moving with the clock. The light still moves at the same speed, but it has farther to go. That means the ticks come more slowly. The moving clock runs slow. This is not philosophy. It's geometry. It's unavoidable. From the clock's own point of view, nothing strange happens. It ticks normally. Each observer insists the other person's clock is slow. And both are right. That sentence alone should bother you. It means time passing is not a single universal thing. It depends on motion. Now apply the same reasoning to distance. If time changes to protect light's speed, space must change too. Objects moving relative to you shrink along the direction of motion. Not because they're crushed, not because atoms get squished, but because space itself is being divided differently between observers. Even simultaneity breaks. 2 events that happen at the same time for one observer do not happen at the same time for another observer moving differently. There is no master clock ticking for the universe. There is no universal now. At this point, many people feel uncomfortable and say something like, well, that's just how things appear. But that's a mistake. These effects are not illusions. They show up in real measurements. Satellites need relativity to work. Particle accelerators would fail without it. Nature behaves as if time and space are flexible, because they are. Now we can return to the idea of a speed limit. Notice what has happened. Light speed is no longer just a fast-moving thing. It has become a boundary woven into the structure of reality. It is the speed that connects time and space. Change it, and the entire geometry of the universe changes. This is why adding speeds doesn't work the way you expect. If you move toward a light beam, you do not see it approach faster. Instead, your measurements of time and space adjust so that the light still moves at the same speed. The universe does the bookkeeping for you. This leads to a subtle but crucial point. The speed of light is not enforced by some cosmic traffic police. There is no rule saying, "Thou shalt not go faster." Instead, the structure of space-time itself makes faster, then light motion incompatible with how cause and effect are organized. If something could move faster than light, different observers would disagree on the order of events. In some frames, an effect would happen before its cause, not metaphorically. Literally, the idea of before and after would stop being consistent. Physics would lose its ability to make sense of sequences. So the light speed limit is really a causality limit. It is the maximum speed at which information, influence, or cause can travel without breaking the logical structure of events. Once you see it that way, the question, why can't we go faster, becomes less like asking for a better engine and more like asking for a different universe. And here's the part that deserves humility. Even with all this understanding, we still don't know why the universe is built this way. We can describe the rules with extraordinary accuracy. We can predict their consequences. But we cannot say why space and time chose this particular arrangement instead of another. What we do know is that our intuition failed because it was trained in a slow, small, human-scale world. At those speeds, time differences are tiny and length changes are negligible. Reality feels solid and absolute because, for us, it almost is. Only when we push nature to extremes does it reveal its deeper structure. The speed of light is the first place where the universe tells us, very gently but very firmly, that our everyday picture of reality is incomplete. And once you accept that, you start to realize that the limit is not an obstacle placed in our path. It is a window into how reality actually works. Once space and time are no longer absolute, the idea of simply adding more speed starts to break down. At low speeds, everything behaves the way we expect. If you walk forward inside a moving train, your speed adds to the train's speed. This works because the changes to time and space are so tiny that we never notice them. But as you move faster and faster, especially when you approach the speed of light, those changes stop being negligible. They begin to dominate the situation. Imagine pushing something faster and faster. Each push adds energy. That feels familiar. But near light speed, something strange happens. The extra energy you add does not go into making the object move much faster. Instead, it goes into changing the object's relationship with time and space. From the outside, the object's clock slows down more and more. Its length in the direction of motion shrinks more and more. Speed increases, but it does so grudgingly. This leads to a result that sounds almost absurd at first. No matter how much energy you keep adding, you never quite reach the speed of light. You get closer and closer, but the last gap never closes. To actually reach light speed would require an infinite amount of energy, not a very large amount, not a cosmic amount. An infinite one. This is not a technological limitation. It is not about weak engines or inefficient fuels. It is built directly into the way energy, motion, space, and time are connected. The equations don't blow up because we don't know enough physics. They blow up because the universe is telling us that this boundary cannot be crossed. It helps to think of light speed not as a finish line, but as a wall that gets steeper the closer you approach it. At low speeds, the wall is nearly flat, so you don't notice it. Near light speed, the wall becomes vertical. Pushing harder just presses you into it without letting you pass through. This is also why light itself behaves differently. Light does not slow down to approach its own speed. It always moves at that speed because it does not experience time or distance in the way massive objects do. From light's perspective, if that phrase even makes sense, emission and absorption happen with no time in between. That is not poetry. It falls directly out of the equations. And this is where many people ask whether nature might allow shortcuts. What about hypothetical particles that always move faster than light? What about clever tricks that bend space? The interesting thing is that whenever physicists seriously explore these ideas, the same problem appears in a different form. Causality begins to unravel. Effects slip ahead of causes. The universe starts contradicting itself. So the light speed limit is not an arbitrary rule. It is a consequence of consistency. It is the speed at which the structure of space-time holds together without tearing. Faster. Then light motion is not forbidden by a sign. It is forbidden because it does not fit inside the logical framework that makes events intelligible. What makes this genuinely unsettling is that we don't know why this framework exists at all. We can describe it, test it, and rely on it with astonishing confidence. But when we ask why the universe chose this particular structure, we run out of answers. At that point, physics stops explaining and starts describing. And maybe that is the deepest lesson here. The speed of light is not a challenge daring us to overcome it. It is a clue, pointing to the fact that reality is not built the way our intuition expects. It is built with rules that are simple, precise, and utterly indifferent to how strange they feel to us. At this point, it is tempting to imagine that the speed of light is some kind of external restriction, as if the universe posted a rule and refuses to explain it. But that picture is misleading. The limit is not imposed from the outside. It emerges from the way cause and effect are woven together. To see this, think about how you decide that one event caused another. You rely on signals. You see something happen, then later you see its consequences. The order matters. If causes and effects could arrive in different orders for different observers, the very idea of explanation would collapse. Physics would lose its footing. Light and anything else that carries information sets the pace at which influences can travel. That pace defines what it means for one event to be able to affect another. If nothing could go faster than that pace, everyone, no matter how they move, would still agree on which events could possibly influence which others. The universe remains logically consistent. Now imagine allowing faster than light signals. For one observer, a message is sent and then received. For another observer moving differently, the same message could be received before it is sent. This is not a trick of language. It is a direct consequence of how time mixes with space when observers move relative to each other. The equations do not care about our intuitions. They insist on this result. Once you allow even a single faster than light signal, you open the door to paradoxes that cannot be patched over. You could influence the past. You could prevent the cause of an effect that has already occurred. The concept of a consistent history would dissolve. This is why physicists say that the speed of light is really a speed of causality. It is the fastest rate at which the universe allows cause to precede effect in every frame of reference. It is not about light as a physical object. It is about the structure that keeps reality from contradicting itself. This also explains something subtle. The universe does allow things that look instantaneous at first glance. Quantum entanglement produces correlations between distant particles with no noticeable delay. But those correlations cannot be used to send messages or control outcomes. They do not carry usable information. The universe flirts with the edge of the limit without ever crossing it. What is striking is how consistent this behavior is. Every time physicists try to sneak around the limit, they find that the universe has already closed the loophole. It is as if space-time itself is protecting its own coherence. Yet for all this clarity, a deeper mystery remains untouched. Why should consistency matter at all? Why should the universe care about preserving causality? We can say that without it, physics would be impossible, but that only shifts the question. It explains why we need causality, not why reality provides it. Here we reach a boundary not of speed, but of understanding. We can trace the consequences of the light speed limit with extraordinary precision. We can build technologies that depend on it. But when we ask why the universe is built so that causality has a maximum speed, we have no deeper principle to point to. It simply appears to be the case. Perhaps the most honest stance is to admit that the speed of light is not a barrier we are meant to overcome. It is a structural feature, like the number of dimensions or the existence of time itself. It is part of the grammar of reality, and like grammar, we can use it fluently without ever fully explaining why it has the form it does. There is a tendency to think that if we just look deep enough, we will eventually find a simple mechanical reason for the speed of light, something like a hidden gear or a cosmic material that resists motion. But every serious attempt to explain it that way has failed. The limit does not come from friction, resistance, or anything pushing back against motion. Empty space does not behave like a thick fluid. Nothing is being slowed down. Instead, the limit shows up as a relationship. It ties together how much energy an object has, how fast it moves, and how it experiences time. As you add energy to an object, its speed increases. But the way that increase happens changes as you approach light speed. Energy stops behaving like fuel poured into a tank and starts behaving like tension in a structure. This is why the idea of mass changing with speed, though outdated in its wording, captured something important. It was not that objects literally gained substance as they moved faster. It was that motion itself becomes harder to change. Acceleration resists you, not because of a force pushing back, but because space-time geometry reshapes the meaning of motion. One useful way to think about it is to imagine reality as a fabric that can stretch but only so much. At low speeds, you barely tug on it. At higher speeds, the fabric stretches more noticeably. Near the speed of light, it is stretched as far as it can go. There is no extra give left. Trying to go faster does not tear through it. It simply demands more energy without granting more speed. What makes this unsettling is that this fabric is not made of anything. It is not composed of particles or threads. It is a mathematical structure that reality obeys. When physicists write down the equations of relativity, they are not describing a substance. They are describing relationships that all measurements must satisfy. This is why light plays such a central role. Light is massless. It does not sit still. It does not need to be pushed to move. It always travels at the speed that defines the structure itself. In a sense, light is not limited by space-time. It reveals space-time. From this perspective, asking why light travels at that speed is a bit like asking why the angles of a triangle add up the way they do in a given geometry. The answer is not hidden in the triangle. It is in the geometry. Change the geometry and the rule changes. But as long as the geometry is what it is, the rule cannot be violated. This shifts the mystery rather than removing it. Why does space-time have this geometry? Why is there a universal speed connecting space and time? We do not know. We can imagine other logical possibilities. We can write down consistent mathematical worlds with different limits or none at all. But this is the one we inhabit, and this is where human intuition runs out of road. Our minds want a picture, a mechanism, a story we can visualize. But nature sometimes answers with structure instead of story. The speed of light is one of those answers. It is not an obstacle placed in our way. It is a window into the architecture of reality, showing us that the deepest rules of the universe are not about things pushing on other things, but about the relationships that make measurement and meaning possible at all. Even after accepting all of this, there is a lingering temptation to believe that the speed of light is merely a limit for matter, not for space itself. People imagine clever detours, shortcuts that avoid the rule without breaking it. Perhaps space could be bent or stretched so that something effectively arrives faster than light without locally moving faster than light. These ideas are not foolish. Physicists have taken them seriously. General relativity allows space itself to expand, contract, and curve. In an expanding universe, distant galaxies can recede from us faster than the speed of light, not because they are moving through space that fast, but because space between us and them is growing. This does not violate the light speed limit because no signal is locally outrunning light. The rule remains intact where cause and effect are concerned. This distinction matters. The limit applies to how influences propagate through space-time, not to how space-time itself behaves on large scales. Space can stretch faster than light without allowing messages to cheat causality. The bookkeeping still works. But even here, the limit reasserts itself. No matter how space curves or stretches, You cannot use these effects to send information faster than light in a controllable way. Every attempt to turn space-time geometry into a loophole runs into the same wall. The universe preserves causal order. This consistency shows up again in speculative ideas like wormholes or warp drives. On paper, the equations allow exotic solutions, but they come with enormous costs. Negative energy, unstable configurations, or conditions so extreme that it is unclear whether nature permits them at all. And even when the mathematics looks permissive, deeper analysis often reveals hidden causal problems. This pattern is telling. The speed of light is not a fragile rule barely holding on. It is deeply protected. Whenever physics appears to flirt with breaking it, a deeper layer steps in and restores consistency. Yet the most striking thing is not that the universe enforces this limit, but that it does so without explanation. The equations work, the predictions match experiments, the internal logic is flawless. But the reason this logic exists remains unknown. This is where physics becomes quietly philosophical without leaving science behind. We are faced with a universe that seems to value coherence. Not in a moral sense, but in a structural one. The rules are arranged so that events can form a consistent narrative across different perspectives. Our struggle to explain this reveals more about us than about nature. We want a final reason. Nature offers a framework. We want a story with a cause at the bottom. Nature gives us a pattern that simply is. The speed of light, seen this way, is not an arbitrary number. It is a signpost marking the boundary of what can be connected by cause and effect. It is the maximum rate at which the universe allows itself to change in a way that can be shared between observers. And perhaps that is the most honest place to stop. Not with a dramatic revelation, but with a recognition of limits of a different kind. Not limits on speed, but limits on explanation. We can explore deeper, unify theories, and refine our models. But there may always remain aspects of reality that are not explained by something simpler, only described by something more precise. When you step back and look at everything we have uncovered so far, a quiet shift happens in how the question itself feels. Why is the speed of light the limit? No longer sounds like a technical puzzle waiting for a clever solution. It sounds like a question about what it means for reality to be understandable at all. The universe could have been built differently. We can imagine worlds where information travels infinitely fast, where every event instantly affects every other event. But in such a world, the idea of sequence would dissolve. There would be no meaningful distinction between before and after. Prediction would lose its meaning. Explanation would become impossible because explanation relies on order. In our universe, the speed of light provides that order. It creates a structure in which events are linked in a consistent way across different perspectives. It allows reality to unfold as a story rather than collapse into a single, timeless blur. This is not something our intuition prepares us for. Our daily experience happens so far below the speed of light that space and time feel absolute. Causes clearly precede effects. The world behaves politely. Only when we push nature to extremes does the deeper structure reveal itself, and when it does, it overturns everything we thought was obvious. What makes this difficult is that we are trying to use concepts shaped by that polite, slow world to understand a universe that does not share our assumptions. We want time to be universal. It is not. We want simultaneity to be objective. It is not. We want faster to always mean later. It does not. And yet, within all this strangeness, there is a remarkable simplicity. A single number ties space and time together. A single limit preserves causality. A single structure makes the universe intelligible from countless perspectives at once. The struggle to explain the speed of light is really the struggle to accept that explanation has a stopping point. Physics can tell us how the rules work and how they fit together. It can tell us what would break if those rules were different. But it cannot tell us why this set of rules exists rather than another. That question may not have an answer in the form we expect. This is not a failure of science. It is one of its most honest achievements. Instead of inventing stories where none are justified, physics draws a clear line between what is known, what is unknown, and what may not even be a meaningful question. The speed of light sits exactly on that line. It is measurable. It is essential. It is deeply mysterious. And perhaps the most important change it forces on us is not in our equations, but in our attitude. It teaches us intellectual humility. It reminds us that the universe is not obligated to be intuitive, only consistent. Once you truly absorb that, reality looks different. The world no longer feels like a machine built from familiar parts. It feels like a coherent structure that we are inside of, trying to map from within. The speed of light is not the edge of our technological ambition. It is the edge of a deeper understanding, where explanation gives way to description and curiosity remains even when final answers do not. At the deepest level, the speed of light forces us to reconsider what we mean by reality itself. We are used to thinking of the world as made of objects moving around in space as time flows along in the background. That picture feels natural because it matches our everyday experience. But the light speed limit quietly tells us that this picture is incomplete. Space and time are not a stage on which physics happens. They are part of the physics. They participate, they respond. They define what can happen and what cannot. The speed of light is the thread that stitches them together into a single structure. Remove that thread and the fabric unravels. This realization changes how we think about motion. Nothing is really moving through time at a fixed universal rate. Different observers carry their own time with them. Different paths through space-time carve out different experiences of duration and distance. The speed of light is the invariant that makes these different experiences compatible with one another. From this perspective, light is not merely a traveler in the universe. It is a reference. It defines the maximum slope that a cause and effect relationship can have in space-time. It marks the boundary between what can influence what and what cannot. That boundary is not negotiable without rewriting the entire structure. What is striking is how indifferent this structure is to human concerns. The universe does not adjust itself to our expectations. It does not provide deeper reasons when we ask for them. It simply behaves in a way that is internally consistent, and that consistency is enough to build galaxies, chemistry, life, and minds that can wonder about it. There is a temptation to look for comfort or drama in this fact, but it offers neither. Instead, it offers perspective. The speed of light is not a wall meant to frustrate us. It is a clue that the universe is governed by relationships rather than substances, by constraints rather than commands. When physicists talk about unifying theories or deeper laws, what they are often searching for is not a faster speed or a hidden mechanism, but a more fundamental description of these relationships. Perhaps one day we will understand why space-time has the geometry it does. Perhaps the speed of light will emerge from something even deeper. Or perhaps it is fundamental in a way that admits no further explanation. Either possibility reshapes how we see ourselves. We are not standing outside the universe, analyzing it from a distance. We are part of the very structure we are trying to understand. Our clocks, our rulers, and our thoughts are all subject to the same limits we are studying. The speed of light reminds us of this in a subtle but profound way. It tells us that there are boundaries not just to motion, but to knowledge framed in human terms. It invites us to keep asking questions, while also accepting that some answers may be structural rather than explanatory. In that sense, the light speed limit is not a disappointment. It is a deep lesson. Reality is not obliged to be simple in the way we prefer. It is only obliged to be itself. And understanding that, even partially, is one of the most remarkable achievements the human mind has ever made. Once you see the speed of light this way, as a structural feature rather than a technological hurdle, it quietly changes how you look at everything else. The universe no longer feels like a place where progress means breaking limits. It feels like a place where understanding means learning why certain limits exist and what they make possible. Without a finite speed of light, there would be no clear separation between events that can influence one another and those that cannot. Every point in the universe would be tangled with every other point instantly. The idea of a local here and a distant there would lose meaning. Physics would have no clean way to talk about systems, boundaries, or interactions. Instead, the light speed limit carves reality into regions of influence. It allows the universe to be stitched together locally, one interaction at a time. Stars form, atoms bind, signals propagate, and histories unfold because influence spreads at a finite rate. The limit does not restrict complexity. It enables it. This perspective flips the original intuition on its head. What looks like a constraint is actually a condition for structure. Just as the rules of grammar limit how words can be arranged while making meaning possible, the speed of light limits how events connect while making a coherent universe possible. Human discomfort with this idea is understandable. We like to imagine that deeper understanding always means fewer constraints. But nature often works the other way. Deeper laws reveal tighter structures, not looser ones. The speed of light is one of those laws. There is also a psychological challenge here. Accepting the light speed limit means it's accepting that some aspects of reality are not negotiable by ingenuity or effort. No amount of cleverness changes the geometry of space-time. That can feel unsatisfying, even unsettling. But it also brings a kind of clarity. We are not failing to surpass the speed of light. We are learning what kind of universe we inhabit. This realization also reframes scientific progress. Progress is not always about overthrowing old ideas. Sometimes it is about understanding why certain ideas cannot be overthrown. Relativity did not merely tell us that light is fast. It told us that the universe has a built-in order that protects causality and coherence across all perspectives. And this has consequences beyond physics. It influences how we think about knowledge itself. Not every question has an answer in the form of a mechanism. Some answers come in the form of constraints that define what questions even make sense. The speed of light sits at that boundary. We can ask how it works, how it shapes reality, and what would break without it. But when we ask why it exists in the deepest sense, we may be asking for something the universe does not offer. This does not close the door on curiosity. It sharpens it. It encourages us to ask better questions, to recognize when we are pushing against the limits of explanation rather than the limits of technology. In the end, the speed of light teaches us a quiet lesson about reality and about ourselves. The universe is not an infinite playground of possibilities. It is a coherent structure with rules that make meaning possible. Understanding those rules and learning to think clearly within them is not a defeat. It is one of the most profound forms of understanding we can achieve. Once you carry this understanding forward, it begins to permeate how you think about time, space, and even existence itself. The speed of light is more than a number on a chart or a technical constant in an equation. It is a manifestation of the universe's internal logic, a safeguard that keeps events ordered, relationships consistent, and causality intact. It shows that reality is not a chaotic playground where anything can happen, but a coherent structure with invisible threads holding it together. Imagine a universe without this limit. Signals could travel infinitely fast. A thought in one corner of the cosmos could instantaneously affect a particle in another. At first, that might seem liberating. We could build impossibly fast communication networks or travel instantly anywhere. But on closer inspection, the concept of anywhere loses meaning. Without a finite speed connecting cause and effect, there is no consistent order of events. Past, present, and future would blur. Predicting outcomes would be impossible. Science itself depends on limits. It depends on the notion that the same experiment performed in different locations or times produces coherent results. The speed of light preserves that coherence. What is remarkable is how subtle yet absolute this preservation is. Every time we push the boundaries, sending particles near light speed in accelerators, observing distant galaxies, or even considering hypothetical faster than light constructs, the universe enforces the same structural logic. Energy, time, and space conspire so that causality remains intact. Nothing cheats. Nothing slips through the cracks. The cosmos is not acting against us. It simply acts according to the rules that make understanding possible. This invites a profound shift in perspective. The speed of light is not merely a limitation. It is the framework that allows the universe to exist as a coherent system. It is a boundary that defines the arena of reality, giving shape and rhythm to the unfolding of events. In a sense, it is the condition that allows the cosmos to be intelligible. Without it, there could be no orderly evolution of galaxies, no chemistry, no stars, no planets, no life to ponder these questions. The light speed limit is woven into the possibility of existence itself. It also transforms our conception of knowledge. We are often trained to think that everything must have a why, a mechanical explanation, a cause hidden behind the veil. But the universe sometimes answers differently. It answers with structure, with relationships, with constraints that define what is possible. The speed of light is one of the most striking examples. It is not explained in terms of deeper machinery. It is explained by the necessity of preserving consistency across all observers and all events. There is a quiet philosophical lesson embedded in this. It teaches humility without undermining reason. It reminds us that not all truths are intuitive, that some limits are not barriers to be conquered, but insights into the fabric of reality. The universe does not bend to our imagination. Instead, it offers clarity through its unwavering consistency. Once this sinks in, our place in the cosmos begins to feel different. We are not detached spectators measuring an external world. We are participants within a finely tuned structure, bound by its rules, yet capable of observing, understanding, and marveling at them. The speed of light is not just a number. It is a lens through which we glimpse the deep architecture of reality, a constant that frames what is possible and what is not, and ultimately, a guide to seeing the universe as it truly is. The limit is not a cage. It is the very shape of the cage that makes existence intelligible.